Welcome, 10th grade. Yeah, Tuesday morning, and today you take your tests. But I thought that maybe I would help you brush up on some problems that you may have been stuck on yesterday. I talked to a few of you, and even one of you asked how far you should go and on Monday, and I told you finish the book. That's what should have happened yesterday. You should have finished the book. In case you didn't, do it this morning and take your test. So I randomly chose some problems again that I thought might be tough. The first one that I chose was 324. Problem 324. You should find it on page 40. On page 40 in your answer key. It says this way, if I read it. It says, Al goes 8 kilometers per hour. Ben goes 20 kilometers per hour in the opposite direction. How many hours has Ben traveled when they are 180 kilometers apart? Okay, so I'm going to let T represent the hours traveled. If you look up here, I put T for the hours traveled. You can draw a map if it helps, makes it clear. The one was going 8 kilometers an hour one way, and the other one was going 20 the other way. And it says, how long did it take for them to be 180 kilometers apart? So the 180 is a total distance. So one was going 8 miles or kilometers per hour. The other's 20. So I put them 8 plus 20 equals 28. I use T for time. So you divide 28 into 28 to isolate the T. That brings you down 28 into 180, brings you down to 6 hours at 6 3/7 hour. And for 6 3/7 hour, I made the 3/7 into minutes. And if you wrote the answer in hours and minutes, you should have come up with 6 hours and 26 minutes. It took 6 hours and 26 minutes for the two to be 180 kilometers apart. Yeah, that one was relatively easy. You were just finding the distance. Now, on the next problem that I have is on the same page, page 40, page 328, and I found this one to be difficult. So that's the reason I'm doing this one. It says, with a certain tailwind, a jet aircraft arrives at its destination 1,890 miles away in 3 hours. Flying against the same wind, the plane makes a return trip in 3 3/8 hours. Find the wind speed and the plane's airspeed. Solve for the wind speed first. Now that's tricky right there, because when I tried to solve for the wind speed first, I tried to find for the speed of the wind, and I was not able to do that. I had to find the speed of the of the plane first, and then the wind speed. So I'm not sure if there's a misprint in the book or if I just don't understand how to find the wind speed. So let me show you kind of some parameters I put in place. I put that the plane took 3 hours to fly. And then I have the rate plus the wind. Okay, the rate of the plane plus the wind speed. And that equaled, my total was 1890. That was the distance, the D. So it wasn't real hard. It was 3 times the rate of the plane, 3 times the wind. And that made me 3 over hour. I took the wind over to this side to subtract it. I had 2 variables. If you see what I had, an R and a W. So I wanted to solve for the rate. I tried to solve for the wind. It came up too big. So I took the wind over on this side, and it was subtracted. The 3W made it negative. You shouldn't look at the bottom numbers here. So that left me with the 3R on top. The rate of the plane was here, the distance here, and the wind here. And now I divided 3 into the rate, 3 into the distance, and 3 into the wind, which would be correct. And so that left me with the rate equaling 630 miles per hour minus the wind. Now I know the book says solve for the wind speed first. I couldn't do that. I came up with the rate first. So the rate of the plane was 630 miles per hour. Now, I worked a whole different problem. I brought it over here, and he says on the return trip, it took him 3 hours and 38 minutes. Okay, I already know that the plane, the rate, was going 630. That's what I found here. So I moved that 630 up here. Now, the wind, I had to subtract the wind. And here where it's tricky, I went 1W here, and I also had to go the second W here. If I wouldn't have had the answer book, I don't think I would have caught that I needed 2 W's. Maybe you did, and if you did, if you stop and think about it, yes, the wind was helping him go, and the wind was helping him come back. So that makes sense that you needed two wind speeds. So you have 2W, and you have the return 630, subtracting the 2 wind speeds. Well, before I go here, I took the 3 3/8 hour, and I just right away went right over to the 1890. And if you can see here from the 1890, I divided 3 3/8 into 1890, and it came out exactly at 560. Okay, so if you have this here, 3 3/8, he comes up to going 560 miles per hour, is what your return trip is. Now, I had the 630 on this side here, so I took it over and subtracted the 630 from the 560. Okay, so that leaves me with a negative 70 miles per hour. Negative 70. If you see here 630 from 560, when I brought it across, well, here I did a little subtraction thing, subtracted the 630 to eliminate that. So I got rid of that. Now I subtracted the 630 over here from the 560. I got a negative 7 and the 2W for the wind. Now, from the 2W, I divided the 2 to isolate the W. I divided, see, I have a negative, so I divided negative into 70, which makes me 35. And that's a positive answer because there were both negative. So both of them are negative, makes me a positive 35. The wind was 35 miles per hour. So, backing up, I have his rate was 630, back to my first problem. So I put 630 here. I subtracted the 35 mile an hour wind speed, and that left me with the plane at 595. So the plane was going 595 miles per hour, and the wind was 35 miles per hour. Yeah, good luck. That's a tough one. All right, the next problem, let me just move over. How's that? Can you see? I did 2 more problems on page 41. On page 41, I did number 330. I found that one to be just a little bit tougher, so I thought I would do that one. And then I also did the first one on page 42, 335. Okay, 330. I'll read it to you. The excursion boat on the river takes 2.5 hours to make the trip to a point 12 miles upstream and to return. If the rate at which the boat travels in still water is 5 times the rate of the river current, what is the rate of the current? Okay, so the boat goes up and back takes him 2.5 hours. I guess he just goes up there and makes a loop and comes right back. 2.5 hours, and he goes 12 miles. So that's 12 miles up, 12 miles back. So I did a little work here. Just the time was 2.5 hours. The distance is a D. The rate is a river. I put R for rate or river, plus 5R, okay? The boat goes 5 times the river speed. Now that's crucial that you get that. The rate is this much plus the river speed. And yes, let me see here, what else? Then I put the time is 2.5 and the distance is 12. So I just put T for time, D for 12. Now I bring it down. Now I'm ready to work the problem. And if you look here, I put the distance over here by itself. No, sorry, the time by itself. Yes, the time is by itself. And then I come over here and I had to make 2 sets of problems. You really wouldn't have had to, because the current was taking him up, was adding on, and the current come back was subtracting it. But I did both steps so it's clear. He went 12 miles. Here the river speed as he was going up, the river speed you had to minus. And here as he was coming back, the river current was helping him go faster, so you plussed it. If you look, the only difference here is the R is subtracted, and here it's positive, it's plussed, the river current. So you got 2.5. You could have skipped that point if you wanted to. It's not important. Here you go. Here you have the rate. If you minus R from 5, you have 4R. And if you plus R with 5, you have 6R. So you got 12 over 6, 12 over 4. You're adding these together. One's up, one's back. The trip. The trip is 2.5 hours. That's total. I put it into a fraction because I've got fractions here. So 2.5 is still 2.5. It's just in a fraction form. 5 over 2, if I say it right. Now, the next point, I come down here and I reduce these guys from the 12 over 4, which make you 3 hour, and 2 hour. Or the rate, 2 over R, 3 over R. And the way you would eliminate that, there's more than one step you can do, but it's pretty simple. Just think about it. If you got the 2 here, that means divide, so I just come over here and I multiply. 2 times 2 is 4. 2 times 3 is 6. That's the way I eliminate this. And I did about 3 steps here, okay? So please follow me here. I'm saving board space. If you see I ran out of space anyhow. So I multiplied 2 times 2 made me 4. 2 times 3 made me 6. You ask, what did I do with the hour? Well, I took the R and I brought it over to this side over here. And I put the R over here. So I got 5R. And now I got 6 plus 4, which makes me 10. And if you can see here, at the bottom, I had 5R, so I wanted to isolate it. I divided 5 into 5. That left me with the R. And now I come over here, 5 into 10 leaves me with 2. So the rate of the river was 2 miles per hour. Yeah, that's a tough one. Let's go over to another one. This one's easier. 3.35. Turn the page to 42. 335, it says Anne is 12 years old. Her mother is 3 times as old as Anne. Okay, 3 times 12, her mother is 36. Anne's 12, mom's 36. How many years ago was her mother 4 times as old as Anne? Okay, so how many years ago was it 4 times? Right now she's 3 times. How many times was it 4? So I come and I let X represent the number of years. Okay, we don't know how many years ago it was, so X is the number of years. Anne's 12, mom's 36. Mother's 36. Now, here's how I set up the problem. I put X subtracted, I don't know how many years ago this was, here, I don't know how many years ago it was, I subtracted, but I put 4 outside. I want 4 times Ann's age. So this here, I put this in parentheses. You had to do this here, well, you didn't have to put it in parentheses, but you were going to have 4 times instead of 3 times. Right now it's 3 times, so you got 4 times minus how many years? I don't know how many years ago it was. Well, that's what we're finding out. So here, to isolate this here, or to get rid of the parentheses, you multiply 4 times 12 and 4 times x. So that leaves you 48 and 4x. Okay, now you just simply have to work the problem out. If you have, I did a couple steps here quickly. I took the 4x over here, which made it a positive, and I subtracted 1, which left me 3x. So basically, I took the 3x to this side, I took my x's to this side, I brought my 36 over here. Okay, so if you see what I did, I brought the 36 over, that means I subtracted 36 from 48, and I got 12, and I brought the 4x over here, which made it a positive. I added 4x to this here to eliminate, I added 4x here, subtracted the 1, makes me 3x. 3 going to 12, and it goes in there 4 times. So, I divided 3 into 3, 3 into 12 equals 4. 4 years ago, Ann was 4 times her mother's age. So you have to subtract 4 off of, if you want to know the exact 4 off of 12 and 4 off of 36. So when Mom was 32, Ann was 8. So when Ann was 8, her mother was 4 times as old as what she was, which is 32. If you have any other questions, don't be afraid to call me. Mr. Wagler is going to be here, and so you can call me if you have questions. You can call me in the morning. I might not be right in front of my books, but you can call me, and I will help you. But today, on Tuesday, March the 24th, you should do your test. Finish up your book and do your test. By the way, Jenna, I see your test is still down in the gym, so if you can't find your test, you come here to the gym. It's on the table there. Have a good one.